Hi, welcome to this lecture on mathematical methods for biologists. We have been studying how to integrate a function. Given slope, how to compute the function itself. And we discussed graphically how to do this. Given a graph, how do we actually compute or how to plot this slope function as a graph, and from the graph, how do we compute the integral. So this is something that we discussed. Today we will discuss more examples of integration. So the thing today is integration, more examples. So the question we would discuss, for example, how do we integrate odd functions and product of two functions, etc. These questions we will try to answer in this one lecture. So we talked about definite integral. We talked about if you have a function 2, which is your function, integral 0 to 1 to x is nothing but plotting the function 2, which is a constant function which is in the red, and take the area from 0 to 1. That's what we learned. And we also said that instead of this, if you have a function which is a straight line, which is like function is x, then if you want to integrate 0 to 2x dx, you plot this function x first, mark the area between 0 and 2, and this area would be the integral, and for which the answer would be 2 in this particular case. And this is of course applicable for all other functions. If you have the function that you want to integrate, your slope function m, s is, let us say, 2x square, and which is essentially your dy by dx or df by dx, and you want to calculate y, you have to calculate basically m of x dx, and we want to calculate this y from some 2 point like 0 to 7. Then what we want essentially is to plot this function 2x square. So we would plot this function 2x square. If I plot, the function would look like this, something like this, 2x square, and I mark this area from 0 to 7, so this is 7, and this area would be answer to this integral. And to do this mathematically, we saw that 0 to 7, 2x square dx can be written as, first you calculate the integral of 2x square, which is 2x cubed divided by 3, and you apply the limit 0 and 7. That is, wherever x, first you substitute 7, minus wherever x you substitute 0, and that would give you the answer 2 times 7 cubed divided by 3 minus 0. That would be the answer. So the answer would be 2 times 7 cubed divided by 3 minus 0, which is 2 times 7 cubed divided by 3. This will be the answer for this particular integral. We also know that if this is not 0, if the lower limit is not 0, still it would be like an area. Like for example, if you want to calculate 0 to, so if you want to calculate, you have m is 2x square itself. Or in other words, we had this example of dl by dt is equal to v. In all this, we want to calculate, this was dy by dx. You want to calculate, we wanted to integrate. Here, if you want to calculate this between it could be 2 and 7. If you want to do this, you could also do this from 2 to 7. The limit need not be 0. In that case, we would plot this function and draw the graph and calculate the area between 2 and 7. So only this area we would calculate, which is the area between 2 and 7. Similarly, if you want to calculate the length, so here we could calculate length as a function of time. So if you want to know that what is the length at 10 given the length at 3, what is the length at 10 minutes given this 3, we would basically calculate the area between 3 and 10. So this is 3 and 10, and this would be integral velocity v dt 3 to 10. And here also we would apply the limit 7 and 2 and we would get this answer. So I urge all of you to do many examples, like from the textbooks that is suggested. Go and do many examples. This is just this course, and in this lecture what one would give is essentially a direction on how to go ahead. One has to do many examples, since as we said that since mathematics is like learning a language, we have to keep speaking, and we might, when we learn a new language, we would speak and we would make mistakes, which is okay, but only when you keep speaking that language again and again, you will learn how to speak it properly. Similar to, like, it's almost like even learning how to bicycle or how to walk first. We would try to walk and then you would fall down and then again try to walk and fall down. Similarly, one has to try solving these problems, and the more problems you solve, the more insight you will get, more ideas you will get. So for the completion of this course, I suggest, or I urge you to go ahead and read textbooks suggested and popular textbooks in mathematics. Read them, do and solve as many problems as you can. And it is important to solve these problems, many problems. Reading many books, it's important to read books. Please do read as many books as you can. And some books you may not understand everything, which is okay. But whatever the parts you understand, you should read it, think about it, sit, go to your room, close it and sit and think about what you read. It's important to think. As much time you read, you would also want to think, and only then you will realize and you will understand things. So think about what you read physically, from the graph point of view, how is it graphically, what are the examples, do think about them. Also solve many problems. Only then you will be able to master the subject, you will be able to answer, you will be able to understand and apply this idea to some other field. So these are the simple ways of doing integral. Now obvious question would be, what happens if there is a negative part? So we would go to this example. Imagine something like this. Like we had this function x, so this is a straight line. We have, if we want to calculate area of this -1 to +1, right? So we would, let us think about this example, which is a straight line function, y is equal to x. So let us take our function is, our slope function m is x itself. And so our dy by dx is x itself. And we know, of course, the answer to this integral, everything we know. What we want to now calculate is integral of this function from -1 to +1. So what we want to calculate integral of this -1 to +1 x dx. This we want to calculate. From the method we learnt, we know that we can calculate the integral of this, and which is x squared divided by 2. Integral x is x squared divided by 2. Then apply the limit -1 to +1. How do we apply the limit? Apply the limit would mean wherever x you substitute 1, the upper limit first. So wherever x, first substitute the upper limit, which is 1. So which is 1 square divided by 2, minus substitute the lower limit. The lower limit is -1. So -1 square divided by 2. What is this? This is 1 square divided by 2 minus, this is half, and this is also half. So this is half minus half. The answer is 0. So the answer to this is 0. So we know that -1 to 1 integral x dx, the answer is 0. Now if we calculate the area, if you think about the area, so let us draw the function here. So let us draw this function. Let us think about the same thing in terms of area, and how do we understand this. So what we have, what we want, we have integral minus 1 to 1 x dx, which is x square by 2 limit minus 1 to 1, which is 1 square by 2 minus 1 square by 2, and which is 0. Now if you think of this as area, we have this function x dx. So the function is basically function is x, and x is a straight line function. So this is the function, and we want to calculate the area. So area from minus 1 to plus 1. So this is minus 1, this is plus 1. So we want to calculate area between minus 1 to plus 1. So how do we do that, and what is the answer we would get? So let us do this. So let us calculate the area here. So this is the shaded area here. And this part is the shaded area. If you just simply calculate the area, this plus this is not going to, let us do this properly. The area looks minus 1. So if I calculate the total area here plus here, you will never get 0, because this is some area positive, this is some area positive, and the answer will be something, a finite number. So what we want actually is a signed area. So there has to be a signed area. That means this area is plus and this area is minus. So and these are same area. The area here is same as this. So this area plus this negative area, which will turn out to be 0. So that's why we would get the answer 0. In other words, what we want is integral f dx, and the function is positive here and the function is negative here. So if I take dx and multiply this function, you would get positive here and you would get negative here. Dx, if you take the dx as a small interval, 0.1, 0.2, 0.3, and the function here is positive and function is negative, this would turn out to be positive and this would turn out to be negative. How this happened? Let us see this little bit more carefully. So let us see this more carefully by taking by understanding this a little bit more in detail. So let us look at this area thing once more. So we have this function, this, which is our x function. Now we wanted to calculate area between 2 points, which is somewhere here and somewhere here. So we have this 2 points somewhere here. So roughly here. So this is minus 1 and this is plus 1. Now when we want to calculate area, what we would do is divide this into small intervals dx. So I will take dx between 0 and 1. I would take this into 5 intervals. So 0 to 0.2, 0.2 to 0.4, 0.4 to 0.6 and 0.8. So 0.2, 0.4, 0.6, 0.8, 1. So 0 to 0.2, so my dx is 0.2. Here also I would do this 0.2, 0.4, 0.6, 0.8, and this is my 1, let us say. So this is minus 0.2 minus negative 0.4 and 0.6 and 0.8 and this is 0.2, 0.4, 0.6, 0.8 and 1. So I divide these into small boxes, each having interval dx 0.2. Now if I calculate the area here, which is this area first, so let us calculate this area first. What we want? You want the y value, the function value, times this area. So what we want? We want function times, we want the function which is a positive number times dx1, which is the first interval, which is 0.2. So the interval is 0.2, the function value is positive, so this will be a positive number. Let us now take the corresponding this part. The interval is 0.2 itself. So here also the dx is 0.2, but the function is negative. So here the function times dx in this side, dx to the negative side, let me call it dx minus 1 if I like. Here this function is a negative number, here is a negative function. So here if I take the value here, the value at 0.2 is 0.2 itself, but here this is minus 0.2. So this would be 0.2 times 0.2. The function value is 0.2, interval is 0.2, and you would get an answer which is 0.04. Here this is 0.2 is the interval, the function is minus 0.2. So the answer will be minus 0.04, and the sum of this would cancel out. Similarly here if I take here, my interval is 0.2, but the functional value here at 0.4 would be some, so the function value here would be 0.4 times 0.2. 0.2 is my interval, f dx. My function, so here the function is positive, interval is positive. Here the function is negative, interval is the same. So f dx, if I do this, positive number, positive, so this area is positive. Here the function value is negative. So this would give a negative function area. Why would this would give you a positive area? Because f is positive here, f is negative here, and these two areas will cancel out each other. So similarly, if I take small areas, since this is symmetric on either side, for every positive signed area there is also a negative signed area. So if I do sum over I f dxi, I would get 0. fi dxi. So in other words, what we would want, let me summarize the same thing in a different way. What we want is integral fi dxi. So I have this function and I have many small intervals, 1, 2, 3, 4. So 0.2, 0.4, 0.6, 0.8, 1, minus 0.2, minus 0.4, minus 0.6, minus 0.8, 1. So I have this small area. So now I calculate each of this area. So this is my function 1 and area 1. So this is my f dx1, f1 dx1. The function value here and the interval here. This one is my f2 dx2. So if I can start 1 from one end, so I could call this as my f1 dx1 if I want, or let me call this is f2 dx2, and this is my f3 dx3. So f3 dx3. So this I would write, so let me write this as this one as f3 dx3. This area would be f3 dx3. This area would be f2 dx2. This area is f1 dx1. Similarly, this area would be f4 dx4. Whatever be this dx times this function value there. So that would be this area. So I can do sum over I fi dxi, and this would give me this total area here, f1 dx1 plus f2 dx2 plus f3 dx3 plus f4 dx4 plus f5 dx5. This would give me the total area here. Similarly, I could do here on this side, this is my f1 dx1, this area would be my f2 dx2. So since the function is negative here, this area will have this f2 dx2 will have a negative sign. This is my f3 dx3. The function value, this is this value times this dx3, f3 dx3, and here I will have f4 dx4, and this is my f5 dx5. So if I calculate f1 dx1, the function here, which is this value times the area value, the width here, the function value here, whatever with that negative value, the function value here, times the dx2, which is this width, this function value times this width, this function value times this width. If I divide this into small areas and again do here sum over I, fi dxi, I would get an area which is negative, and this total area would cancel out and one would get 0. So another way of thinking is that just to understand, one can just simply say that if I have a function which is like this, and if I divide this into many small areas like 1, 2, 3, 4 here, and similarly here 1, 2, 3, 4 here, I could call this many small areas 1, 2, 3, 4, 5, 6, 7, 8. So I have this 8 small portions here, and I could write the integral of this function as basically sum over I is equal to 1 to 8 fi dxi. I take this first small area, this is my dx1, and the corresponding function here multiply f1 dx1. So f1 dx1 plus f2 dx2 plus f3 dx3 plus f7 dx7, which is the area of this part, plus f8 dx8. So I could do this, and this would give us this area approximately. This would be approximately equal to integral f dx. From this limit, whatever be this value, let me call this a, to whatever this value which is b. A to b can be divided this. Now this 8, the more smaller areas I take, the better answer I will get. This approximate sign is because when I divide this into boxes, the more number of small boxes I take, more accurate answer I will get. And there are many different ways of getting this answer accurately. So this is the numerical way of finding this integral, and there are many different ways one can do this, and there are different methods to how accurately one can get it. But the bottom line is that integral f of x dx, which we could write as the following. So integral f dx a to b can be written as sum over I is equal to 1 to n fi dxi, and the more n you take, the larger the n. So here instead of equal to, I should write approximately equal to, because larger the n, more accurate the answer will be, more precise the answer will be. So this is something that we would want to know, that we can calculate this area like this. Now this need not be for a function like this. We could think of some function, let us say, which is integral sine x dx. So let us say our function is sine x dx. So we want to integrate, our function is sine x, and we want to calculate integral sine x dx 0 to 2 pi. So if I plot sine x from 0 to 2 pi, what I would get? I would get like this. So this is 0 and this is 2 pi. Now we can see that there is a positive part and negative part. If I divide this into small areas, one would see that whatever be this value, there will be a corresponding equal negative value here. So therefore, if I just, for example, this is 1 and this is minus 1. So this point is pi. So pi plus delta value is same as pi minus delta. The only difference is on a sign, right? So sine x is symmetric around this point. Therefore, this area will be positive and this area will be negative, but equally negative. Therefore, this answer will be 0, because there will be two signed areas, positive and negative. They will cancel each other and this answer you would get 0. Think about it, do this yourself and convince yourself that this is 0. And this is true for all odd functions. So this is also true for all odd functions, which we would see. Let us see that if you have a function, what is an odd function? If you have a function which is f of x is equal to minus f of minus x. If your f of minus x is equal to minus f of x. If you have f of minus x is just take f of x and minus f of x. What is the example? So let us take an example which is x e power minus x square. This is our function. This is our f of x. What is f of minus x? So where I minus x e power minus x square is x square itself. So this is. So here f of minus x, which is this, is f of x with a minus sign. So this is an odd function. Where we have f of x, take the f of x and put a minus sign, you will get f of minus x. So such integral, for example, from minus infinity to infinity, so minus infinity to infinity, x e power minus x square dx would be 0, because if I plot it for every positive x value, there will be an equivalent negative x value with an opposite sign. So these two are equal up to a sign. So these two functions, x e power minus x square and minus x e power minus x square, are same except for this minus sign. So I multiply with a small interval 0.0001 and sum this. For every positive value I will get a negative value and this would cancel. So convince yourself, plot this function x e power minus x square and convince yourself that this answer would be 0 from minus 1 to plus 1, minus infinity to plus infinity, or any minus a interval to corresponding minus plus a interval. So in general, any minus a interval to plus a interval, this answer will be 0. So to summarize, we learned a few things. We learned that if we graphically compute this integral for odd functions, that is functions which is negative part and positive part, when they are equal, then you would get 0. And more important lesson we learned is that integral is a sum of signed area. So the two lessons, very important lessons to take away is this, that is integral f of x dx can be written as sum over I fi dxi. This is one important lesson. And we learned that signed area if you calculate, you will get the integral. The sine, you have to put sine and area. These are the two takeaway summary lessons, and with this we will stop this lecture and see you in the next lecture.